So by the end of this lesson, you should be able to know how to prove this formula. So this formula, some students call it almighty formula, and it is a formula we get from general quadratic equation, which is as squared plus bs plus c equal to 0. So today, by the end, you should be able to prove it yourself and feel it. So now we have our general quadratic equation, that's as squared plus bs plus c equal to 0. So we are going to use this general quadratic equation to prove and show that s is equal to this. So now let's move on. We are moving on by using the method of completing squares. So to use the method of completing squares, we should be able to ensure that the coefficient of s squared is 1. But here it is a. So meaning we have to divide through by a. So now let's divide through. Let's divide through by a. Let's divide through by a. So now, when we divide through by a, here we left it s squared plus b over ax plus c over a equal to 0. So the second thing to do is to send the constant, which is not in terms of any variable, which is s, send it to this side. So we have s squared plus b over ax is equal to minus of c over a. So after sending the constant to this side, then take your time and find half of the coefficient of s. Here the coefficient of s is b over a. So now let's try to find half of it. So we have half of means times b over a. So on this note, we are going to get 1 times b, 2 times a is 2a. So meaning we are going to get 2a. When we get the 2a, we have to square the b over 2a and add it to the both sides. So we have s squared plus b over as plus b over 2a all square is equal to minus c over a plus b over 2a all square. Now this is like how to solve quadratic equation using method of computing squares. So now let's form our perfect square. Our perfect square is x plus b over 2a all square, because these two terms carry the squares and b over as is in between. So when we expand this one, we are going to get this one back. So which is equal to minus c over a plus b power 2, meaning the b square over 2a power 2 or exponent 2 is 4a square. So on this note, when we look at the right side, we have to take our time and simplify the functions here. So now we have x plus b over 2a all square, which is equal to a and 4a square. Their LCM is 4a square. So let's simplify. A goes into 4a square. 4a times c. We have 4ac, that's negative. Because 4a goes into 4a square is 4a times negative c is minus 4ac. Then bring your addition sign plus 4a square goes into 4a square 1. 1 times b square is b square. So now let's move on by rearranging the numerators here. We have x plus b over 2a all square, which is equal to, so I'm rearranging the numerators. We have b square minus 4ac all over 4a square. So on this note, Now, let's eliminate the square here so that we can solve for x, or we can make x the subject. So, by doing that, we have to take square root on both sides. We have s plus b over 2a all square is equal to root of b square minus 4ac all over 4a square. So on this note, when you take square root of a number, I told you earlier that it's plus or minus. So we have x plus b over 2a is equal to plus or minus root of b square minus 4ac all over root of 4 is 2, root of a square is a, so all over 2a. So on this note, let's make s the subject by sending this term forward. We have s is equal to, is positive, so we have minus b over 2a plus or minus root of b square minus 4ac all over 2a. So on this note, we can clearly see that these two fractions are sharing one common denominator, 2a, 2a. So you can choose one denominator as we have minus b and add plus or minus root of b square minus 4ac all over 2a, meaning the 2a is common denominator for these two fractions. So we have to choose one denominator and add or subtract the numerator.